How's it going, everyone? Welcome to Lab 3. As I mentioned in the intro video, along with the course checklist, this lab is going to be shorter than Lab 1 and Lab 2. In addition, since it's getting up 2 days later, I'm going to extend the due date from this Sunday until a week from now. So you'll have about 10 days to work on it. However, I think you'll find that it's a pretty quick lab, and you might just want to knock it out over the weekend, especially if you're devoting some time just to try to stay on schedule. So this lab, we're going to cover the basic I/O. That is an acronym that's often used for input and output in computer science. Another term that you see used for this class of functions is UI, or user interface. Functions that we covered in Lecture 4, Module 3. And if you just want to watch the particular video from Lecture 4 that covers these functions, you'll want to click on this hyperlink right here, and that will take you to it. And what we're going to be turning in is a script, meaning that we're actually going to upload an M file. I will have the type of files that you're able to upload restricted, so you can only upload an M file. And what I would like you to do is to write a script that performs these actions. So let's go through them. The first action, we want to prompt the user to enter their favorite integer between 1 and 10. And we want to use the following prompt, particularly, what's your favorite number between 1 and 10? Specifically, what I'm looking for there is how you actually enter a literal string with a contraction in it, which will force you to have an apostrophe. So you might remember, if you watched this Module 3 video already, around the 335 mark, I talk about the two characters that you can use in order to delimit strings within MATLAB. And that's just a fancy way to say start and stop strings. So you can both use a single apostrophe or a single quote along with double quotes. However, if the string that you want to store, the literal string, has an apostrophe in it due to a contraction, you have to use double quotes, and we'll see that in a minute. In particular here, we're told to store the result of that user input in a variable called user val. So note that that is a good variable name because it not only satisfies the MATLAB syntax rules, in this case containing only numbers, but it's also good because it's descriptive. We're using camel case to kind of give the reader of our code an indication that what this is doing is storing a user value. Action 2, we want to use the randi function to generate an integer between 1 and 10. You'll notice that that range is the same as what we prompted the user to enter a number between. We want to store that result in a variable called randval. Again, good, because it's not only syntactically valid, but also is semantically meaningful. And then in action 3, we want to display a message to the user that displays both the value they entered along with the value that was randomly produced. And what I'm going to show you here is we're going to need to concatenate different data types here. Particularly, we're going to have that message, which is a literal string that we're defining. And in addition, we're going to want to display these numbers that are going to be stored by default as doubles in our software. And in order to put all that together in a message, we're going to get to look at a function for what is known as typecasting. And typecasting is where you take a variable that's stored as one data type and you force it into another in order to put all of that together, in this case, strings. And that process is called string concatenation. What we're going to find is that's pretty similar to the way that you actually defined matrices or vectors in MATLAB, because you can kind of think of matrices or vectors as being numbers that are concatenated together. So like usual, I'm going to turn off my video, that way I can maximize the size of my screen. You're going to want to open MATLAB Online, and you're going to want to create a new script. So new script you can either do directly by clicking on the new script button, or you can arrow down on new and then choose script. Remember that this is the option you want to do if you're going to be writing a function, because you'll automatically get that header syntax that we spoke of in the lecture videos. Actually, that was Lab 2 video. So usually when I'm writing a script, before I get started, I'll actually put in comments for what I want to do. So I want to prompt the user for a number between 1 and 10, but I have a specific prompt. Sorry. So what I'm going to do is I'm going to say, initially, I'm going to define my specific prompt. And then I'm zooming in here a little bit. That way it's a little bit easier for you all to see. So I'm going to define I'm going to call it user prompt. And of course, these are comments, so it wouldn't matter at all, but it just will make more sense to me. Then I'm going to prompt the user, and then I'm going to generate the random number. And then I'm going to display my final message. If you think about it, those are all the things that we have to do. So as long as we know how to write code that does each of those things, we're going to be in good shape. So what is the user prompt that we want to say to them? It's what's your favorite number between 1 and 10. So I'm going to actually type that in here, and I'm just going to type it with no delimiters around it for now. But the key point is, since we have this apostrophe, even though there's two ways in which we can define literal strings in MATLAB, I'll kind of show you here on the command window. I could say method 1 here, that defines a valid string. That is using single quotes or apostrophes around the literal value, or I could use double quotes, method one in this case. You notice that both produce the same results. However, when I have an apostrophe in the literal string that I want to define, I'm forced to use double quotations in order to not confuse MATLAB when I actually define that string. So I'm going to say that this is my user prompt, and I'm going to terminate with a semicolon. That way, when I execute this script, that prompt won't be echoed directly onto the command line. I want to control how that is actually echoed. And looking at what we want to do here, we want to prompt the user with this message, but we also want them to enter a value that we're going to store in a variable called user val. Now, you might remember from the actual lecture that I linked to in lecture 4 that the function that's built into MATLAB that you actually want to use is called input. However, if you don't remember that, it's good to get some practice in kind of exploring what functions would achieve what you're particularly trying to do. So you might think about what you're trying to do and you're like, hey, that might be something that's called input. So you can type help on the command line and start to type the word input. And you'll notice that that is an actual function name. You can tell it's a function by this f of x before. I'll tab over since it's the first option in order to complete it. And if we scroll up, we can get some example syntax here. And I showed you all this in the lecture video. If you want to store an actual numerical result based upon giving the user a prompt, the way that you do that is you use the input function. It takes as input, if you notice here, a prompt string. We've already defined our string here. And then what we want to do is store that result in a variable. Now, we were given a specific name that we wanted for that variable. It was called user val. So I'm going to say user val, and I'm going to assign this variable the result that happens when we use the input prompt and we pass to it the specified user prompt that we wanted. Now, you might ask yourself, well, why didn't you just type the string directly into the input function? And that's certainly a valid way to do it. I tend to like whenever I have any identifiers that are defined that could potentially be used more than once to always define them in a variable. So that's not necessarily a criteria that would make you define this in a variable because I'm only going to use user prompt once. However, I just think it makes your code more readable to see, okay, this is the user prompt that I want to pass. I'm going to pass that user prompt into this function. And now if I want to me, it's cleaner. Now, I think that people that have coded a long time would debate whether or not it's best to actually pass the string directly into the function or have it defined before. Usually the rule of thumb is if you're going to use a variable more than once, if you're going to use a literal value more than once, like if I were going to pass this string into multiple input functions, I would certainly define it as a variable. But since I'm only using it once, it's really your call. I think it makes more readable code. So a good practice as well is whenever you're writing a script, you don't want to wait to the end to see if it actually works. So I'm going to CLC to clear my command window. I'm actually going to save the script, and you can't see the actual field in which you enter the file name because I'm too zoomed in, but I call it Lab3. You can call it whatever you want, ENGR 2304. And then what you might want to do is actually just run this script to make sure that everything's working the way that you would want. So I'll click the run button, and what would I expect to see? Well, MATLAB will sequentially execute line 1 and 2. Line 1 should define a variable in my workspace that contains this string, and then line 2 should prompt that string on the actual command window, ask me to enter a value, and then store it in user val. So when I hit run, and if I clear my workspace, just so I don't see anything there, I would expect user prompt to show up in the workspace. I would expect that prompt to show up on the command window. And then once I enter a number, I'd expect user val to show up in the workspace. So let's run it. And we see what's your favorite number between 1 and 10. And sorry, I have defined user prompt in my script. And this is why it's good to do. That way you can kind of take that out and move it to the end there. So there we go. Obviously, it won't affect the way that the code executes this time, but just good to do in advance. So I put 5. And you notice there is the value that I entered along with my prompt. I can clear everything again. I can wipe my command window. And now that I move this command outside of the outside of the literal string, when I re-execute, I won't see that anymore, of course. So maybe I pick 3 this time and I see everything stored correctly. So now let's talk about how I would generate that random integer between 1 and 10. So if I look at that, the function that you want to use for that is called randi. And if you notice, randi is an overloaded function as well, meaning that there are multiple kind of input combinations that you can pass in depending upon what you want to do with it. Notice that if you just pass in a single value, it will return a pseudo-random scalar integer between 1 and whatever that maximum value is. So again, kind of along the same lines of what we were saying earlier, you could actually define a variable called like maxval equals 10. You call the randi function, you could pass in the maxval. And that's just kind of, again, just making your code a little bit more readable. Someone can see, they must want to generate a random integer between 1 and this maximum value. It doesn't make it seem like 10 is a magic number in case you're unfamiliar with this syntax. Now, notice that that's not going to be good enough. I want to store the result of that random number generation in a variable. And particularly, I want to use the variable called ranval. So let me assign this new variable that I created, ranval, to, sorry about that, copied it in the wrong place. I want to assign that random variable, and let me zoom in again. I know sometimes it's hard to see when you're watching this on YouTube, but I'm going to assign that the output of the randi function, which is passed a parameter of maxval, to my ranval input. And again, this is something you might want to just check and see if it's working. I'm going to zoom out a little bit more, go to my command window. I'm going to uncomment this. And probably what I would do, to be honest with you, is rather than rerun this whole script, I would just copy this line of code. And of course, you're going to need to copy the definition of the maxval term as well. And just run this a few times and make sure it's producing random values between 1 and 10. So 4 is a valid output, 9 is a valid output, 6 is a valid output. It looks like it is working here. So we have a ranval. So we've done 2 of the 3 actions that we need to do. The final thing that we need to do, if you go back to the actual lab here, is we want to display a message to the user to show them the value that they entered along with the value that was randomly produced. And we kind of want to add a prompt in there. And I mentioned that this is going to deal with the concept of actual typecasting variables. So if you look at maxval and ranval, and you were to use the class function or expand your workspace, you can see that each of those variables is actually stored as a double. And that's related to a concept that we've talked about a lot throughout the class so far, which is the idea that MATLAB is an implicitly typed language, meaning when it actually determines what data type to use, if you create a new variable and you assign it a numerical value, it will automatically put it in a double precision floating point number. So it takes way too much space to store something that it doesn't need to. So if you notice, if I try to let me just show you the function, num2str. What this is actually going to do is exactly what it sounds like, convert a number to a string. So if I pass in maxval to that result, you'll notice that it gives me maxval previously had the double 10. And when I pass that into number 2 string, or num2str, I get what looks like a string with the number 10 inside it. If I re-execute that command and put the class function around it, you'll notice that what that function is doing is it's actually returning this char that's like a character array. And in MATLAB, it's good enough to just think of character arrays and strings as the same thing. Because if you look at this string, it's basically just a bunch of characters put together. And hopefully we'll have time when we move to a little bit of lower languages, languages that are closer to the silicon, like C++ or C, that you do have to be careful between the differences between strings and character arrays. But for now, just treat them the same way. So let's look at some strings and things you can do with them. So if I take and I say, I define a string called my, and then I define a second string called string down here on the command window, and then I put those 2 things inside square brackets, and I separate them by a comma, notice that what that is doing is it's actually concatenating the 2 values together. So this is how you do string concatenation. You might note that, hey, I want a space in there, so I could either lead string with a space, or I could close the my with a space. Either way, the process for concatenating strings is to actually concatenate them exactly like you would arrays. You can use square brackets and you can separate them by commas. So if you want to display this final message to a user, well, first and foremost, what function are we going to need to use in order to display? You might remember from the lecture video that that is the actual display function. You could use the help function to see how you need to actually call it. Notice that you can just pass values directly into display. So going to the description here, display X is called for the object X when the semicolon is not used to terminate a statement. So what that's telling you is MATLAB itself is actually calling display whenever you don't use a semicolon. But for now, let's just actually use display explicitly. What it was saying with X being an object is you can really put any kind of data type in here as long as it's the same kind of data type. So what I'm going to do just to make my code a little more readable is I will say before I display the final message, I'll say I want to generate the final message. Here's what's going on, right? When you try to put a message together that says something like you picked, and then you want to put a number in here. I'm going to do this the wrong way intentionally first. Remember that the value that the user entered is actually stored in the variable user val. So say you tried to put together like a message that said, you picked this value, and then we say, the computer generated, and then we go to, and you notice MATLAB there was closing that with double quotes, or it was using double quotes in order to encapsulate the string. Either is okay. And then I say I tried to append to that the value that the computer generated, which is stored in rand val. So let's just see what happens if, and remember, user val is defined, max val is defined. So I can take and I can just copy this on the command line and see what's going to happen. There's not going to be any issue with that. If you notice what's going on, though, is there's these question marks wherever I would try to actually insert user value and random value. And what's happening is MATLAB doesn't know how to combine these literals here, which we've defined, which are strings, and these actual double or numerical values. So I'm going to call this string to display. Again, I'll use camel case notation. But what I need to do is actually to pass user val and rand val into the num to string function. And that will basically make them strings. And then MATLAB will know how to put them together. So notice if I do that, and I just take this line and I copy it again, and I run it in the command window, helps to actually type the function name correct, not mum to string, but num to string. If I run that, you notice that now it knows how to interpret, kind of concatenate the numbers 3 and 6 together because I'm converting them to strings before I'm combining them with the rest of the literal strings. So once I have that, all I need to do is call the display function. And again, as I was explaining to you earlier, technically, if we just didn't put a semicolon on the end of this string here, that's concatenated, it would do the same thing. But just for good coding practice, I'll take all of this and I will run it on my command window now, and let's see what happens. Going to the command window, it's asking us what's our favorite number between 1 and 10. I pick 4. It says I pick 4, and the computer generated 4. So what's the likelihood that would happen? Well, assuming that this rand I function generates each integer between 1 and the maximum value with equal probability, right? I would expect that since there are, let me make sure I get this right, 10 integers in there, that I would have to have 10 trials, 1 out of every 10 trials that would happen. So it's like a 1% chance. But let's run it again here. Pick 3, maybe I'll get lucky again. If I had 3 there, I would be going to the casino tonight if there was a casino around, but there is not. So I picked 3, the computer generated 10. That's the outcome that I would expect 9 out of the 10 times. So this is looking good here. I want to actually, I think we're all good. Yep, this is good enough for this actual code. One thing you might want to do, so this is the actual M file that you want to turn in. I don't think you should have any issues. Like, I'm trying to think, like if you want the easiest way to actually turn this in, is you just copy it and open up like Notepad on your machine. This is assuming that you're using MATLAB online. And just when you save this in Notepad, ENGR 2304 Lab3, and then actually explicitly put in .m and then change the file types to all types. And then I will be able to actually open this in MATLAB and verify that your code actually works as functioning. So hopefully that was a nice lab to you. It allowed you to review the function of the actual input function, introduce the concept of a random number generator within MATLAB, particularly the random integer generator, reviewed concepts of just general variable syntax and best practices in writing scripts with respect to commenting and picking meaningful variable names, and in addition allowed you to learn the concept of string concatenation. So that's all that you have to turn in. Pretty easy lab. Just basically, if you followed along, take exactly what I had there and upload it to the portal. So it should be, again, about 20 to 30 minutes for total submission time. So I will get the exam review uploaded, and good luck with that. and reach out if you have any questions.